these are my steps for my rule Goldberg machine. So now I'm going to describe my machine. So from step 1 to step 3, I used a marble, which is a wheel and axle, and a lever. And from step 4 to step 6, I used marble, the wheel and axle, and dominoes, the lever. And from step 7 to step 9, I used the dominoes, as I said before, a lever, and a marble, the wheel and axle. And I used the incline plane. And step 10 to step 15, I used marble, which is a wheel and axle, and a ramp, incline plane, and then dominoes, which is a lever. So at first, the KE and the GP will be at different spots. KE will be at 0, but GP will be at the middle, because the tube and the ball is not at the ground, but the ball is moving in the tube. And at last, at the end, KE will be high, but GP will be low because the ball is still moving, but it's at the ground. The secondary energy diagram is from the ball hitting the dominoes on the ground to a chopstick. And the last energy diagram is just basically all the dominoes at the end that was hit, including the last one. So now I'll talk about the 3 steps about changing direction. So first step is this domino over here. This domino change the direction from 0 degrees to 180 degrees like this. And when this domino fell, it will cause this book over here to change degree from 270 to 90 degrees like this. It will flip this book. And the first step I choose is this green ball over here. This green ball will change the degree from 0 to 180 like this. It will fall down. So I choose this incline plane to be the friction part because friction acts a very important role on this incline plane. And because if the friction is too high, this marble may not reach over here and continuing my Goldberg machine. And how do I make this ball move faster? First, I can let this incline plane be more steeper and change the material. And how do I make it slower? I can make it not less steep and change the materials too. So as for air resistance, I choose this part because air resistance acts most on it. So let's talk about this ball. So this ball is not that big and it's light, so like this chopstick will hit this ball and this ball will move like very smoothly and fast towards the stairs over there. But if this ball is very big, then first of all, this chopstick may not have enough force to hit this, and air resistance might act on this ball because the big ball has larger surface area. And I can make this ball move faster by making it more smaller and lighter. So now I'm going to talk about my force and the pressure of my last step over here, like this. So the falling time of the last domino falling from the table to ground is 0.6 seconds. So I times this number by 9.8. So the answer is 5.88. So I times 5.88 with 0.19 because the domino over here weighs 19 grams, so I convert that into Newton, so the answer of my force is 1.1172 Newton. And now the pressure. My pressure for this domino, the last step, is 0.12, because like the area of here, over here, this area is 2 times 5 equals 10, and the force from the force over here is 1.1172, so I divided this by this, so it equals this. So this is my work done, and because the distance between my domino and domino is 5 cm, so it's 0.005 meters, so I times this distance, I times the distance and force together. The force of this domino over here is 1.862, so then I multiply times them together equals 0.0931 joules. So the work done of this is 0.0931.